Okay, we are back. I hope you had a good break. And now we'll have a talk from Marlus, who's going to talk us a little bit about Surface and how you can use Surface with LiveView and how those interact. And so without any further ado, I will give way to Marlus.
Hi, Luis. Hi, everyone. Okay, so just let me share my screen. Okay, so let's get started. So I'm Marlus Saraiva. I work at Dashbit, and I'm here today to talk a little bit about Surface and some new stuff that we are preparing for LiveView. So recently, we published a blog post at Dashbit explaining some more of the recent efforts to bring a better component model to LiveView. So this talk will basically go through the main topics, and we are trying to clarify each one of them. So the first thing was the motivation. I mean, the motivation to create Surface happens a couple of years ago when I had a talk at Alchemy Conf, and I wanted to present a live dashboard of Broadway. So it looked like a real good opportunity to try out LiveView, and that's exactly what I did. So the first impression I have from LiveView, from the experience with the Broadway Dashboard, was that it was absolutely fantastic. Having the logic on the server close to the data makes everything much, much easier. And the productivity gains I had was amazing. I was really surprised to be able to do everything I did in the dashboard without even using any custom JavaScript. So it was a very good first impression. However, I had the feeling that it still needed to evolve to a more component-based approach. So I felt it was like, and this model was like introducing live component, but was extremely limited from the point of view I had. So what was missing in LiveView back then? So first thing was the limited stateless component API. Actually, the API had a live component, which you could create stateless component, but there was a lot of limitations on that approach. Another thing missing was a template engine that could understand the structure of the template and provide some good information about it. The last one was the lack of a declarative interface for components. So let's start with the first one, limited stateless component API. So the main problem was that you can't reuse stateless components. You couldn't use stateless components in controller-based views or in layouts. So if you had a stateless component using live component and you try to use it in a controller, you get an error message because live components cannot be in a context of a live view. So people start trying to find alternatives, and one alternative was to design those stateless components into pure functions. The problem was that functions and live components didn't compose well. So if you ever try to add a live component inside a form, you certainly have seen this error because you just can't inject, you can't use live components inside functions, and form for it's actually based on content tag. So you had this model where we could create a stateless component, but you couldn't use it in other areas of the system. So the other problem was the template engine, right? I mean, EX is great, but it makes no distinction between plain text and structured format like HTML. So you can actually do whatever you want. You can inject code wherever you want. So there's a lot of important information that you're missing because you have a structured format, but the template engine is ignoring all that information. And this is critical for live view. This was critical because if there's something wrong in that structure, since live view has to map the state of view components in the server, any problem in that structure can make live view completely misbehave. And if you ever forget to close a div of a stateful component, you probably have seen this problem because lots of different areas of the view can be updated, and you just don't expect that. And it's just because of a silly mistake that you forgot to close a div. So the last one, the last item, the last gap that I was feeling in live view was the lack of a declarative interface, a declarative API to define the interface of the components, because after all, components are just building blocks, and you want to use those building blocks to build other building blocks. But in order to do that properly, you need to know the shape of those building blocks. Otherwise, you don't know how to compose them. So it's critical to have a declarative interface. So with no declarative interface, whenever you need to use a component, you need to answer those questions by yourself. Which assigns are public and can or must be passed to a live component? I mean, you need to know what the component expects so you can provide that information. What's the type of each assign that you can pass to the live component macro? Which of those assigns are required? So if I don't pass them, will they receive a default value or not? So this is all important information you need to know when you're going to use a component. And if you don't have this declarative API to define it, you need to trust the developer that he's going to properly document that information, which usually doesn't happen. Another question, it's which assigns represent the internal state of the component and which assigns are part of the public API. So this is all important information. So how Surface handle that? What Surface can do? So from those three issues we had in live view, Surface could address two of them, which is the HTML component aware template. So we have a template engine that actually parses the template and gather information of the template, validating its structure. And the other one is the declarative API to define components. So we have a way to define the shape of the component. So how we do this in Surface? So you can see this is a Surface template, and it's pretty much like an HTML template. And you can see the card is component, and you can see it has properties. The class property receives a dynamic value, and you can see that it's not much different from a regular HTML tag. So with that model, having that template engine, understanding the structure of the template, you can do a lot of stuff for the developer. For instance, if it miss the ending tag that we talked about the div or any component, it can just raise a compile time error and give you much faster feedback instead of just seeing the application completely misbehave. So you can have precise message because now we are parsing that structure, and you know that you forgot to close that tag, or maybe you mistype it. So the other issue you addressed in Surface, which was the declarative interface, we created this API where you can have this declarative model of defining the shape of the component. So a great thing about this is because you can express in that API, you can express the clear separation of what is public and what is private about that component. So as you can see here, we have a public API of the component that you can describe it in properties that you can pass as attributes in the HTML. And you can also have slots, which are larger chunks of the templates that you can also pass to the component. So you can do this stuff in LiveView before, but you need to find out yourself. I mean, you usually have to go into the template to take a look at and see how it's handling this stuff. And it doesn't, LiveView doesn't have yet a slot API. I hope it will have in the future because it's really handy. It helps a lot the user to use that component. And you can see here, you can also define the private assigns. So it's really nice to have this clear separation. When you go to a template and you just see a bunch of assigns there, it's really important to know which assigns are public, that is supposed to be passed from the template, and which ones belongs to the internal state. So those are the ones that you're going to change in your handle events. So, and it is not supposed to be changed by the user. So let's see some benefits of having this approach. So those two things combined, you've seen already how Surface can handle a syntax error, right? So a mistyped tag. However, we have two things. You have the information about the structure of the template, and you have the information, the declarative information about the component. So with those two pieces of information, you can cross them, and then you can go even further on the static validation, right? So you can see this, it's a completely valid piece of code on the syntax point of view. However, you can make, by crossing the information of that the structure with the information you have from the component, we can see that there's something wrong in the semantics. You're trying to use a property that was not defined in the card component. So it's really powerful. It can really help a lot because we can give really fast feedback at compile time. You can also provide an introspection API, so you can generate documentation, which is great. So remember, you need to know the shape of the component. So you have something that can generate that automatically, telling you what's the public API, what are the properties, the slots, the events. It's going to be much easier for you to understand that component and use it properly. You can have a lot of additional tooling if you have those things in your component model. So the Surface Catalog is our first attempt to bring something like Storybook to Surface and LiveView. And it's only possible because you have this introspection API and you have this model when you can actually see what the component expects and what are the types of the information that he receives. So you can have a lot of stuff on top of that model. So you can have precise formatters. If you have been following the Elixir forum for some time now, you're going to see that a formatter is still a problem in EX. And that's exactly because it doesn't recognize the structure, so there's no validation on the structure. So it's really hard for a formatter to do a proper job if you can inject code anywhere in the file. So you need to remember that we are generating a structure file to go to the browser. And if you don't validate that, it's really hard for the formatter to do his job. You can also provide autocomplete and suggestions for editors, because we can introspect information about most of the details of the component. You can also create converters. For instance, the upcoming version of Surface, which is 0.5, will ship with a converter that will translate all invalid syntax into the new one. This is only possible because you can parse that template. You have that information, so you know exactly which pieces you need to replace for the new syntax. And a bunch of other stuff you can do if you have that model. So this was not present in LiveView, and it was a bit frustrating for me. So that's why I invested my time trying to bring those stuff. So there's still an issue that we couldn't solve in Surface, and it was the stateless component API. Unfortunately, this could only be done in LiveView itself. So fortunately, we were able to contribute to LiveView back. I mean, after all, we have been using LiveView. We love it. So it was the right time to contribute back to LiveView. So about a month ago, I think, I submitted a PR introducing the component macro, which provides a proper API for a stateless component. So now we're going to have a live component and component for stateless. So with the component macro already merged, already available, we are filling the last gap we had in our component model. So it's really excited to be at this point and see how things are moving. So after this first PR, there was another one, which we introduced the Hicks template engine. So the Hicks template engine, it's built in LiveView, and it's also a component HTML-aware template engine. So it solves that first gap of not parsing the structure. So if you're using LiveView and you, in the future, use Hicks instead of the leaks, you're gonna have all that validation about the structure, which is really cool and was one of the main pain points in LiveView. So basically, the difference from Hicks and Surface is that Hicks will try as much as possible to keep compatible with EX. And in Surface, we don't have that constraint, and we don't want to have it. So here's an example of Hicks. So if you see, it's really similar to Surface or any other templating language, which is React-ish or something like this, Vue or Svelte. So as you can see, in the attributes area in the component, you can see that it's pretty similar. And the big difference is going to be inside the body of the component, because it's just EX. So basically, we have this, it's like the new model, and whatever comes inside the body, it will be just like regular EX. So it tries to keep this compatibility, although it's not going to be possible to to be compatible if you have interpolation inside the attributes area. So it's not 100%. It's not exactly an extension because it's not compatible. It tries to be compatible as much as possible. So regarding liveview, it's already, Hicks is already there. It has been merged. So currently, it only supports stateless component. So you cannot define live components using the same syntax. It will eventually have proper syntax for live components, but this hasn't been defined yet. So the new model in liveview, we still don't have the declarative interface either, but conversation has have already begun in that direction. So in liveview, I mean, bringing that component model, it's an effort that's gonna take some time, but I think the most important aspect, which was the component macro along with the template engine, those were like the two main blockers. So I think now there's a big chance that we can evolve much faster. So the declarative interface will come also eventually, so you can have the benefits that we can already have in Surface. So the goal, I mean, the whole blog, if you want more information, you can read the blog post. There's probably more information or maybe some different information, some things that I could focus on a blog post that I was not able to do here. But the goal of this effort is to establish Phoenix as this great foundation to write components, regardless of the template engine. Because the important thing that you need to have in liveview, it's the component model. It's not actually the template language. The template language is something that you can use. You can choose whatever you want. But the component model is important to be in the core, because otherwise we need to do so much in Surface to mimic that behavior, and it doesn't make any sense to do that. So I am really glad that the Phoenix core team is moving in that direction, so we can contribute to liveview and slowly start to bring this model. So we're doing this very in trying to do in a very safe way, so we don't have much trouble. So it's really excited to have this common goal. So one thing you can ask is, so okay, so since you're moving some of those features that you have in Surface to liveview, so what's the point in having a different templating language? Why not just using Hicks? For me, not trying to keep compatibility with EX gives, it opens a bunch of opportunities. So, but not trying to keep this compatibility with EX, we have a chance to create this tailor-made language for templates. So we have the opportunity to have this DSL, which is more suitable for templates. You can have this language being much simpler. It can be much safer because it doesn't allow the user to inject arbitrary code in the template, and it can certainly be much more friendly to new users. We can also provide better ergonomics. Remember, you don't have that constraint. You don't have to keep the compatibility, so we can come with some fresh ideas regarding ergonomics. We can have better static checking. I mean, we just have a very small subset of the language. We just have a way to go through things and print things, a couple of conditionals, and that's all. I mean, we don't need more than that in a template. I mean, you can still use Elixir, of course, in other parts, in the events, in all in other parts of the code. But inside the template, the more restricted you are, the better. You can do more because it's predictable what can be done in the template. So it also avoids common pitfalls that we have when you're using a general purpose language like Elixir in the template. So in EX and also in Higgs, you can actually inject any kind of code, but the thing is you're already using a different language. So EX, it's not actually Elixir. There's a lot of things in Elixir that you can't do, that you cannot do in the template. So the use of pipes are very restricted. Whenever you don't have a full expression, so whenever you're mixing template code with Elixir code, you cannot use pipes. The use of pipes is restricted. Anonymous function, it's also restricted. So that's why you always need to use the for comprehension to print items of a list. You can't use anon map, for instance. So it is already a different language. It's not Elixir. There's other limitations, variable assignments and reassignments. There's a bunch of stuff that you cannot do. So in my opinion, it's much better to have 4 building constructs in the template that are specific for the template and can be customized and optimized for handling templates than trying to bring a whole language with all its complexities like Elixir to the template view. And if you take a look at at other solutions, you're going to see that most of them are in this direction. Most of them provide this DSL for the template. You can see that in Svelte. You can see that on Vue.js. Most of the solutions. React is a little bit different, but it accepts JavaScript, but actually it's different because React extends JavaScript. So you can actually use the templates. You can inject tags and components directly in the JavaScript. So it's actually an extension of JavaScript. So EX, it's not an extension of Elixir. It's actually a more restricted version of Elixir to work with templates. So here's a couple of examples that we're going to have in the new 0.5 version. So it's really common in a template. You have to go through a list and render each item of the list. And if the list doesn't contain anything, you render a message informing that there's no items. So you see this all the time in EX or in Surface. So on the new syntax, we are having a new block expression syntax in Surface. So you can have now a for else construct. So I'm going to be honest, I never miss for else in doing any kind of backend stuff. Never. I've been doing this for more than 20 years. I never say, oh, I wish I could have a for else, because you usually don't need it on the backend. Because usually on the backend, it's mostly about transforming data. And if you're transforming data with a for comprehension, the next steps probably expects a normalized data. So if you have a for comprehension manipulating a list and the list is empty, the next step of this pipeline will accept the empty list. So we usually don't need this on the backend. But when you're handling the view, usually when you're going through a list of items and the list is empty, you usually just don't present an empty page. You usually present some kind of message telling that there's no items in that list. So this is something that I didn't want in Elixir. I don't want to have a for else in Elixir, but it seems to be pretty handy to have this for else in the template, because we do this all the time. We are always going through lists and printing their values and send it and showing another message if they have no items. So I think these kind of things can be done when you have a different specific language just for templates. And we're also going to have the if else, because one of the things I said that I wanted is that Surface can be friendly to new users. And I don't think our Conf, which is like the equivalent of this, it's very friendly for new users. I mean, every single user knows what a if else is. It's present in every language. So it's much friendlier than I need to introduce the Conf. Okay, if you have to do this, use Conf. And here the else is going to be this weird true arrow. So, I mean, there's no need to do that, right? We have another language. You have another context. It's a template. You're free to be more friendly with the user. And we're also going to have some shorthand syntax for a couple of important things, like using slots, since it's so common and we use a lot. I mean, I was really surprised to see people using. I knew it would be something that would be really appreciated in the language, but I got surprised that people really love it. I mean, really using it's a very nice abstraction to work in components. So we are making the syntax better. I mean, in also that sense, I mean, we are taking feedback from the users, and we see that the users using this a lot. So it's nice to be able to come up with customizations in the syntax to provide a better visualization of the template. That helps a lot. That's ergonomics. That's things that we can do for the user. We're also going to introduce the concept of tagged expressions. With tagged expressions, expressions, depending on the context, can have a tag at the beginning, and you can add some syntactic sugar. So for instance, in the current syntax, if you have, if you want to assign a value to an attribute, and the assign is the same name of the attribute, you can use this shorthand syntax with the equals sign as a tag in the expression, so you don't have to repeat the name of the attribute. We also have the three dots tag in the expression, which is similar to the spread operator in JavaScript, but it's not an operator. So we really want, since Elixir doesn't have the spread operator, we don't want to confuse the user. So we create the concept of tagged expression. So the three dots, it's related to the expression, not directly to the variable that comes after. So we might add other in the future. We have a couple of ideas already, but this is something new in the new version, and we're starting to explore a new idea, some few ideas. So this is basically what I have for this talk. You can have more information about Higgs in the blog post, and you can always contact me on Twitter, or you can open issues on GitHub. Could be related to Surface itself. It could be related to the new stuff we have in liveview. So I'll be glad to clarify any doubts you might have. So this is what I have today. Thank you very much.
Thank you, Marlus. So yeah, let's go. We have some questions. Let's see if we can go through all of them. And the first one is, do you think that Surface, that with Surface and a proper component implementation, liveview will overtake React usage for complex Phoenix apps?
I think it can take a big chunk of the market, especially on these larger projects for enterprise, this kind of enterprise applications, where the whole thing about using components is that you end up losing a bit of flexibility, right? Because you're writing everything inside a component, specify an API, and whenever you need to change something, it's not just to go down there and change here in a page. When if you change this, it's going to have a bigger impact in the system. So for this kind of systems that you usually have like hundreds of views, those views are usually following the same pattern. So you have everything that is usually data based. So you have data that you're going to send to the database. You have hundreds of views, and you're going to reuse those components. Those components should look pretty much the same. I think there's a big chance we can replace React in that direction, because you don't have to do many things in JavaScript. I mean, the kind of interactivity you get for LiveView, it's really enough for most of the cases I've ever seen in my career. So I don't think it would replace React, but I mean, I would replace React for most of the applications I've seen in my lifetime. So especially because I mostly worked with this kind of large enterprise systems, like financial systems, accounting, and all that stuff. You don't need to have all that JS magic. I mean, you usually are gathering information from the user, sending it to the database, showing reports, doing calculations, and all that stuff. You usually don't need JS to do all that stuff. So yeah, I think there's a big chance we can get a big chunk of that market.
Cool. That ties up nicely to the next question, which is, does Surface have any JS integration? And then they add, it's not that intuitive to pass events from LiveView to Alpine.js and vice versa, for instance.
There's nothing specifically regarding Alpine.js. What we have is, in my opinion, a nicer way to create hooks on top of the already existing API on LiveView. So in Surface, since we always try to create specific components for each view, usually you have this kind of one hook per component. Whenever you need to use a hook, usually you have this mapping from one component to a hook. So it turned out to be really nice to have a way to have a co-located JS file along with the component itself. So we could automatically get this JavaScript with a custom compiler, and with some minimal configurations, we can automatically have this co-located JS file bound to the component. So you really have this configuration once, and whenever you have a component and you need to have a hook to interact with JS, you just have to create a co-located file with the same name and a specific extension, which as far as I can remember, it's .hook.js, and you can reuse those hooks also by the name of the component, so they are bound. They have some static validation on that. So I think it's much nicer to have this co-located hooks file along each component, then have this big chunk of JavaScript on the app.js. So this is one of the things that we've done, and there are other ideas that we are taking into account for the future.
Yeah, that kind of covers the next question, which is if you can use hooks in Surface. You just answered that. And
yeah, sure.
If there's any other JS interrupt features that are available or planned, so maybe you want to get into that a little bit.
This is like a very gray area, because there has been some discussion about using like the same approach you had for the hooks for CSS, right? So you can have co-located CSS files which could be scoped by the component. So you can write any generic style, CSS style, in that co-located file, and those styles would only apply to the component, which would be great, because you don't have this style leaking, right? I mean, you define a style here, and it could leak to other components. This all takes some extra effort, because you need a custom compiler, just as we did for the JS. And unlike JS, that we could find some minimal standard to do that, on the CSS side, it's a complete mess. I mean, there are so many different ways to address this in a modern web application that we couldn't find yet the best way to do it. So we are actually trying to come up with some maybe unifying idea to have this scoped CSS along with more things in JS. But for now, we need to first to discuss a lot because there are too many things, and every 6 months there's a new thing to do that changes completely the way you work with CSS. So that's where we are right now.
Okay. Yeah, next question is, how does the live view and surface roadmaps align? Does it overlap? Are there breaking changes?
The new Hicks template, it's not 100% compatible, right, with leaks. So yeah, there are breaking changes. Regarding Surface, the new version 0.5, there are also breaking changes in the syntax. But as I mentioned before, we are providing a converter that the user can run a mixed task, and every breaking change in the syntax will be replaced with the new syntax. So Surface and Live View will, on the syntax front, the template language will go their own directions based on their goals. So Hicks focus on keeping compatibility with EX, and Surface focus on having this smaller template language that is much with better ergonomics. They shouldn't be, the goal is to move everything beneath this, right? And take all the important aspects of the component model and bring to live view, so they actually will be component at the component level. I mean, you can, the future, what we want to achieve is that you can create a component in Surface and you can use it in Hicks. The same way you can create a component in Hicks and you can use it in Surface without any limitation. Because today, although it's possible to use Surface components on live view directly, on leaks, since Surface has much more features, and some of the features are built on top of the existing model, you can't use Surface components in live view directly because we have more stuff, and that stuff needs, which belong to the component model. So that's stuff that we need to bring to live view before we can achieve this goal.
Okay. Cool. Next question is, what needs to happen to increase adoption of live view and Surface? Is there any missing features, visibility, teaching resources?
I think one thing that we are trying to address in Surface is to be more friendly. I think there's this sense in the Elixir community that Phoenix is friendly, which I think it is, but it's not for most of the users out there. So the project structure, the templating language, the macro, the couple of things in live view that use more macro than I think it's possible for a new user coming to understand. So if you're coming from JS, if you come from React, and then you just try Phoenix for the first time, there's a lot of concepts that you need to understand. So you have a completely different template language. You have macros that it's used everywhere in Phoenix. You have the functional model. It's a functional language. You have OTP. You have so many things that in the template language, I think it's one place where we can do this. We can be more friendly. So that's what we're trying in Surface, especially in the new version. So there are other things that I think we can do on the project structure side. I think we could have a way to have like a minimal project to get started, because right now, even if you create if you generate a project with Phoenix New, even if you use all those no HTML, no actor, no whatever, you still have things there that it's more information than the new user needs. You have information about channels. That I think channels is like the greatest feature in Phoenix since the beginning. It was what got attention in Phoenix. But I think with live view, I don't see myself using channels as much as before, because most of the things you're doing using channels, we are already doing live view in a much more in a much more simple way. So I think it could start removing this and maybe have this something similar to create new app in React, like you can create a minimal application with React, and it's actually just one template file and a couple of other files. I think you should have this same thing in Phoenix, and if you don't have, I would try to have this in Surface if possible.
Okay, cool. So last question is, so you during the talk you mentioned stateless components a lot, and someone here is confused about the missing stateless component statements because Phoenix Live component references stateless components. So maybe you can clarify that.
Well, you can create stateless components with the Live component API. The problem is that you cannot use those components if you have a view for a controller or in a layout. Those are the dead views. So you cannot use them in that view. So it's kind of weird because they are stateless, right? So if they are stateless, they should probably be used in anywhere, right? Because the thing is that they're not, because if they're based on Live component, the Live component macro, if you use it, you cannot, the Live component macro can only be executed inside the live view. So what we are doing now, it's actually with the component macro, it's actually can now define components that are stateless components, and you can reuse those components not only in live views, but you can reuse them in dead views. So you can use the same if you create a table, right? And you want to use it in a controller view, you can actually add the same component there and use it, even if it's in a controller or even if it's in a layout. Using pure, because there's the distinction. It's a stateless component. It's not the same as a pure function. You can do a few stuff with a pure function. You just have to use the CGU L, and then you have the code there. The problem is when you want to have this component as a container, so like a form. So in a form today, if you use a form in a live view, and then inside that form you want to inject a live component, you're going to get an error. So there's this, I know it can be confusing, but it's different. I mean, a pure function, it's something. And then you have the stateless components that can be created with live component macro, right? But this will be deprecated in the future. So whenever you want to create a stateless components from now on, and you want to reuse these components throughout the system, you're going to need to use the component macro. If you want to create a stateful component, you're going to use the live component macro.
Cool. That's all in terms of questions, also in terms of time. So thank you, Marlus, again for the talk and for being with us.
Thank you.
Bye.
Bye-bye.